Okay. Looks like I have a couple other remote attendees. So I want to welcome everyone who's attending remotely as well. And one thing that I always enjoy doing with ChatGPT is I can have it write a nice introduction. So I have left a slot in the program for an introduction here. And so I asked ChatGPT, give me a 2-paragraph introduction on Artificial Intelligence Symposium. And it took some liberties and made some guesses what I might be doing, but it's pretty good here.
Neil?
Yes.
Magnify that.
I'm going to magnify this. I was going to read this, but I couldn't. So I'll just read this up. So what it says here is, welcome to the Artificial Intelligence Symposium, a premier gathering of experts, researchers, and innovators exploring the transformative power of AI. As artificial intelligence continues to redefine industries, from healthcare and finance to creative arts and autonomous systems, this symposium serves as a platform to discuss cutting-edge advancements, ethical considerations. Isn't that nice to know that ChatGPT considers ethical considerations important? And the future of human-AI collaboration. Attendees will engage in thought-provoking discussions. Well, there's certainly lots of space to ask questions on the presentations. Witness groundbreaking demonstrations. I can hope some of that will happen. And network with leaders who are shaping the next era of intelligent technology. This year's symposium will feature keynote speeches from industry pioneers, panel discussions. Well, okay, I don't have any panel discussions on emerging trends, and interactive workshops that provide hands-on experience. Any of my speakers doing anything hands-on? Huh? With the latest AI tools and methodologies. Whether you're a seasoned professional, an academic researcher, or an enthusiast eager to understand AI's impact, this event offers valuable insights and opportunities to contribute to the evolving landscape of artificial intelligence. Join us as we navigate the challenges and opportunities of this rapidly advancing field and explore how AI is revolutionizing the way we live, work, and innovate. So yeah, I have noticed that ChatGPT sounds very cheerleader rah-rah when you ask it to do things like, I have had it write a course description for the course I teach for the governor's school, and it has a similar kind of, it's like, oh, this is the best thing since pre-sliced cheese, which there's plenty of in the back if you want to have some. Yes.
I think you misstated a little bit there. You said it's nice to know that ChatGPT considers ethical considerations important.
Yes.
I think it's better to say that it says that it considers.
Yes, I guess we don't know what it thinks, but certainly if it's putting it here, it must mean that it's encountered it lots in all of the text that it has, if I use a British term, hoovered up. So that's nice to know. All right. Well, given that it's 2:04, I am going to try to stick to this timeline so people who want to come to a later talk will have the time matched. And again, lots of breaks. If you can only come for some talks, feel free to come to the talks. But without further ado, I would like to get our first talk going. And I have Chuck Ebert from Colorado ready to give a talk. This is I think it's a mini version of the talk he gave at the assembly. I think he's cooked up a little bit of tidbits targeted to our undergraduate audience a little bit. You can tell more about this, but I am going to surrender the screen to you. I think when you launch your PowerPoint, it should fill up the whole screen. And I'm just wondering if let me see, where can I access the chat? There's the chat. I can ask Grace, Faith, or Fernando if you can see the PowerPoint presentation on the screen. Just give me a chat if you can. And let's give it up for our first speaker, Chuck Ebert.
Thank you very much, Dr. Simonetti. Can you see my PowerPoint?
If you go if you start the presentation, I was told it should fill up the whole screen. Right now, it's filling up about half the screen. So if you actually go into presenter mode, I think it might fill up the whole screen.
I think I've already started in presenter mode. I brought up the PowerPoint and I screen shared.
But I can see the slides on the left side margin.
Oh, you can't see the center?
So in other words, not only do I see the main presentation in the middle, I see the slides, the whole deck of slides along the left margin. And
Yeah,
then we
that's
didn't presenter mode. So if you go into slideshow on your menu and start the slideshow, I think it'll take up the whole screen. So yeah, slideshow. And do
Slideshow.
from beginning. All the way on the left from beginning.
Yeah, I'm clicking slideshow, but I'm not getting anything.
All the way to the left. Can you see it on the left? I see it. There's something called from beginning. There you go. Click on from beginning. Oh, you were on button. There you go.
Now can you see the full screen
Yeah,
slide?
now I'm gonna start finding other pieces of the screen here.
So is that okay?
What's that?
You pop it up.
Oh, I can pop it out. Oh, pop it out. Oh,
Make sure
right.
you.
Come on, move it. There we go. Okay, now you got it full screen. Take it away. It's all yours.
Thank you very much. Yeah, Dr. Simonetti said this is a modification of a show a workshop that I did at the General Assembly last summer, and that's true, although it's been strongly modified. Every day I keep adding something else, and hopefully I won't run over the time. I can see a little picture of the audience there. I'm pleased to see a number of my students from CS 220 this term, which just finished that class. And I've got some great students in it, and some of them are making presentations today, so I will look forward to that. And I'll have some comments about your ChatGPT in a few minutes. Okay, these are the main questions. And I have centered this not just around the technicalities of ChatGPT and artificial intelligence, I should say, but around the concept of how does that impact the new church and how does it impact the world? And those questions are very much interrelated, of course. So let me figure out how to change to the next slide.
I think you hit the right arrow key. That'll do it.
There we go. Artificial intelligence is, in a sense, an old science. It kind of grew out of progress made in mathematics and computer science and even physical science basically since World War II. So it's an old topic. Some of the things that have come up are language translation. Back in the old days, they thought that if you just got a big enough computer and big enough dictionaries in it, you could translate languages. Well, it's a lot harder than that, as you can imagine, because it's not just a question of word replacement. There's a whole lot of, grammatical and other nuanced things that go into translation. Simulation is a topic that comes up in the sciences and applied sciences, because often there are problems, let's say in physics or engineering, that you can write a set of differential equations that are a model for those, but you can't solve them. They are insolvable, so you solve them by numerical means, or sometimes you just simulate the system. You write a program in C++ or whatever that seeks to mimic the behavior of the system. So you put in as much information as you can, and you let the computer draw a graph of the behavior, things like that. You could do that with, for example, the orbit of the moon around the Earth. But those equations can be solved, so you don't have to. But you could simulate something like that. Some things are very nonlinear and very complex, and so they have to have simulations. And then natural language processing is a field that's a little bit newer, and it probably includes language translation, but it also includes picking out topics, looking for similarities in style and format. We're going to talk a little bit more about that later. Let's see next. It's not doing next.
That's the right arrow key. I'll make it the right click.
Okay, so what progress has been made? Well, again, these things that I mentioned before, but we also have to fit in data mining, which is a way to look at mountains of data. I mean, anything you want to do is data mining. You collect the temperatures in your hometown over a period of a year and draw a graph of it. That's data mining. But much more complex things, we have mountains of data that we don't even understand. And so data mining tries to find patterns and similarities within those. It's part of machine learning. It's lately become very popular. Back in the 60s, an engineer invented something called the perceptron, which was supposed to mimic what nerves do in the human brain. And that led to what later was called neural networks, which I'll mention in a minute. And then we had the internet that came along, spreading information and disinformation. And then we had Google, which was a massive search. I mean, when Google came out in the mid 90s, that was a really big thing, the Google searches, that is, because that gave everybody access to all kinds of information. Some of it was just pure garbage. Some of it was not well organized, but some of it was. And then more recently, natural language processing, large language models, which is ChatGPT, and things like that. Many people have used, millions, hundreds of millions of people have used ChatGPT, but that comes from what's called generically a large language model. And finally, image recognition and classification. Those last two are the ones that I want to emphasize in my examples that I will show you. The purpose of this, by the way, is to give an a sort of a non-technical introduction to artificial intelligence, but with forays into the technical area that might interest some of the people who are more deeply involved in computer science. So here's a very rough graph, which probably changes every couple of months, of the interplay between all these different fields that I've been mentioning. And you could say, well, this graph is one man's opinion, and it is, because you could say the whole thing is data mining and I should draw a big circle around it all, or the whole thing is computer science, and that would be a big circle around it all. But computer science, as we now conceive it and teach it and use it, impacts these things, but it's not, they aren't entirely subservient to it. So this diagram is supposed to show how these things are somewhat interrelated. If I put up the same diagram in 2 years, it won't be correct. There'll be new things, there'll be different relationships. So it's just a hint at what's going on. All right, large language models, they came out in 2021, at least to the public. ChatGPT being the one that everybody hears about. There's one that I use called Perplexity, which I think is really good, better than the old ChatGPT. They're very popular. There's lots of hype. There's lots of worry. Chatbots are useful, and OpenAI is one of the ones you can access. I mentioned lots of hype. When Dr. Simonetti showed his ChatGPT introduction to this seminar, well, that's what hype is. Also, people talking about, oh, it's going to revolutionize the world. Well, it'll change some things, but I think it's overhyped. And I think it's overworried. When in 2021, when the large language models started to be used by large numbers of people, there were people wringing their hands saying, well, all jobs will go away because artificial intelligence will do everything. Well, it seems unlikely to me that there are certain things that humans can do, and we'll talk a little bit about that, and certain things that humans can't do. Like artificial intelligence probably won't do surgery. Although I recently had a knee replacement and my doctor used a computer-driven robot to do some of the work. He wouldn't let me stay awake to see it, but because I was curious, but he said that would be too painful. But he was right there, so it wasn't labor saving. He had to be there the whole time, but it was perhaps more accurate. All right, one of the ways of looking at this sort of philosophically, if Dr. Sinisfeld were here, he could have some comments on this. But
He is
there's
here.
oh, he is there. Good. Hi, Dan. There are two large group ways of thought: induction and deduction, and these apply to human thinking, human writing, and also computing. Computing by a computer. For reference, induction is where you go from many examples and you try to come up with a general principle. Deduction, you start with a general principle and you derive specific cases. Deduction is very typical of mathematics itself. You start with some axioms and some general principles that are agreed on, and you derive answers to specific problems or new theorems or new concepts. In the sciences that are more experimental, for example, you might do lots and lots of experiments and finally come up with I see, that's how that works. And the same can be true with computing. You can emulate both of those modes of thought. The deduction is a lot easier because of the logic that's internally used in the computer. Back in my youth, I used to design navigation systems keep in mind the induction and deduction. I used to design navigation systems for aircraft and ships and stuff. That was all based on science. That was all deductive, based on physics and electrical engineering. You get signals from the outside like GPS and your inertial navigation systems and so forth, and you blend those together and try to reduce errors, and you get a picture of where you are and where you're going. I would not ride in an airplane that was being driven by artificial intelligence. It's not that good yet. And you don't have to in this case because you know the physics of it. But the inductive approach where you examine zillions of examples and then try to work your way through it wouldn't make me too confident to ride in that plane. Okay, neural networks are the buzz that everybody talks about these days. I'm going to show some diagrams in a minute, but there's two main categories. There's really more than that, but the two specific things that I want to talk about as exemplifying artificial intelligence are the large language models, which we mentioned, and image recognition and classification. This used to be, image recognition used to be really difficult, and it's been made much easier by using neural networks. I worked on image recognition for an aerospace firm 50 years ago, I guess, and we didn't have neural networks. And it was very, very clumsy trying to make distinctions between objects in the air, for example, what type of aircraft, those kinds of questions, in order to classify, really crude things like this is a friend or an enemy. But since neural networks have been invented, image recognition is a lot better, works a lot better. Now, this is all done in computers, so how does the data get there? Well, in the case of large language models, you scrape the web, you can read documents and books. It's easy to picture the data. For example, all the writings have been scanned or many, many years ago and are online, and so they can go into a large language model. But if you're going to talk about Google, by the way, sort of pioneered the web crawlers, which go out and find new websites, unclassified websites, and grab all the data. And then that becomes part of their database that allows you to search everything. If you want to talk big words, petabyte is 1 million gigabytes. And as you probably know, a gigabyte is 1 billion bytes. And a byte is roughly a word or a half a word. So there's a lot of stuff out there. Now, images are different. How do you get an image into a computer, a picture? That's not as obvious as getting words in. Well, there's a picture. Some of you might recognize who it is. It's a famous picture. But here's a blurry image with very low resolution because the little blocks are quite big. Here's the same image where the blocks, by blocks, I mean the little squares there that you can see. Some of them are light gray, dark gray, really dark gray, black, and so on. And that's classically known as a grayscale. This is a black and white picture. And what you do is you divide your picture up into however many squares you want, typically a couple thousand for a photograph. And then you measure the light intensity that comes through. Let's picture a negative, for example, that can emit light. And you register the degree of light that comes through. So almost no light would be a black square. A little bit more would be a dark gray one, and so on. Then those become numbers, and those numbers fit in computers very nicely because that's what computers do. Anybody want to guess whose picture this is?
Is Abraham Lincoln?
Yep. So when you see a picture, you don't know what it is. It's always Abe Lincoln. But so you take pictures and you turn them into numbers. And that's how you get data into the computer. That doesn't mean it can recognize them, but it does get the data there in a form that the computer can use. So here's a picture of a sort of a neural network. Let's say you want to be able to distinguish between cats and dogs, and that's very easy to do now. So you take a bunch of pictures, just like I showed with Abe Lincoln, and you feed that into the computer, into the input layer. Within the neural network, there's a hidden layer, and then there's an output layer. There may be 25 hidden layers, but just for simplicity, I show one. And attached to the connection between the input and the hidden and the output are weights. And so you train the neural network by repeatedly, you do what's called supervised learning. You repeatedly tell the computer that it's got the right answer or didn't until it eventually adjusts the weights through something called backpropagation, so that the weights give you very accurate outputs when you submit pictures to it. And they're sensitive enough that if you train it between dogs and cats and then show a different cat, it'll identify it as a cat. It takes a lot of processing, but there's a lot of computer power around. Here's another example of a neural network: input layer, hidden layers, that should be plural, and an output layer. And again, what the computer does is figure out what the weights should be on those arrows. Okay, large language models, how do they work? Now we're getting away from image processing and back to language. Well, they use neural networks, they use neural networks to make predictions. It's the same looking neural network as this. It has an input layer, hidden layers, and output layers. But they're using words, and they're using words to make predictions. In a simple case, the neural network is trained to pick the most likely word or words that follow. A simple one is, boy, I'm really on Abe Lincoln today. I just read a book about him. I guess that's why. Phrase completion, 4 and we can all complete that. So it goes through these petabytes of data, and it looks for all examples of strings of words that it sees. And so it's able to make the most likely through training through a neural network thing. It's able to, it's able to come up with the highest probability for the next word or phrase that follows an input phrase. So when Dr. Simonetti says, give me a good outline for an artificial intelligence symposium, it's actually filtering through through megabytes, maybe gigabytes of data, and taking his input words and coming up with sensible sentences. Of course, it was kind of overdone, overhyped, but that's how they work. And it's a big process. Sometimes some neural networks take, like a chat GPT thing will take petabytes of data from, let's say, from the web and from books that have been digitized and so forth. And it'll sometimes take 2 or 3 months to do the processing, to do the back propagation, to figure out what those weights should be for the layers. So it's not something you can do on your home computer, at least on that scale. Okay, applications to Swedenborgian study and life. Realize I'm running out of time, but that's okay. The two main areas that we talk about in the new church and in Bernathen College are outreach and education. And I've been contemplating for a long time, well, how can AI help those areas? One of the things that's currently an issue is I've been talking to the people in the outreach department of the general church, and we're getting so many queries from our websites and other things that we have, like these ones listed down here, that the people who have agreed to respond to those are getting too much more work than they can possibly do. So I'm when I get the time, I'm going to experiment. Can we develop an AI system that responds to people's questions? Like, what does the new church teach about whatever? Or why isn't the new church bigger than it is? Or, you get all kinds of questions from people who visit websites who are not familiar with the new church, have never been to any church congregation or anything like that. So I would love to develop an automated way to respond to that didn't sound automated. And we have our own chat bot where the ratings are emphasized more than other data. Stay tuned. I think my friend Levi has a presentation on that if I ever stop talking. Okay, well, I'm looking towards the future here of mathematics and computer science. Mathematics is my field. And how can those things contribute to artificial intelligence? And part of what I have in mind is that some of my students and other computer science students who are in this meeting might be motivated to do a senior project. We used to call them senior research essays. To do a senior project involving mathematics, computer science, AI, that kind of stuff. Dr. Simonetti tells me that I'm still licensed to advise senior projects. Is President Conley in the audience?
Yes, he is. He is.
Okay, good. Well, back in the day, he was one of my students, a strong student, and I was his advisor one of his advisors for his senior research essay. So I've been doing this for a long time, but not since I retired. I haven't been doing that sort of thing very often, but I guess I'm still licensed to do it. So I make myself available for internships and senior projects, that kind of stuff. One of the future fields that is really intriguing is knowledge graphs. How can we figure out the interconnection of ideas? They can come out of a large language model, but the end product isn't a chatbot. I want to give it some data and see what it can figure out from it. I can take a lot of forms. For example, I fed to a knowledge graph that I found online. I haven't developed a knowledge graph myself, so I'm using other people's work. I fed it Divine Providence number 50. And this is what it came up with. It came up with a graph of the main ideas. This is the outermost box of the graph, and I could not, and trying to blow this up and capture it, I couldn't get that one involved, so I just drew it in. So it comes up with a tree-like structure showing the interconnections of the concepts and so forth. I'm not saying this would replace um, sermon writing or anything like that. But it might be a way for students or newcomers to grasp new ideas from the writings that are not yet part of their normal vocabulary if they didn't grow up in the new church. So I think that's an interesting possibility. I'd like to spend some time on it. Here's another one from Apocalypse Revealed 176. I know you can't read those words, but it's a more elaborate diagram that it came up with when I submitted that particular passage to it. Okay, I was going to say the big picture. It's one big picture. We had Google in the mid-90s. Google wanted to turn, the founders said that their goal was to turn information into knowledge. A very interesting thought, and it largely works. The information is just out there at random, but it's turned into knowledge when you ask a question. I'm not talking about a chatbot or anything, just what Google does. You've all used online searchers. And then some of the people who, like chatbots, have wanted to turn information into knowledge and that into wisdom. I have serious doubts about that, but that's one of the stated goals. You go beyond the knowledge into the wisdom. Artificial general intelligence is supposed to be an expansion on what we're doing. You hear mentions of AGI, but a serious limitation on that is the degrees of the mind. Did I see Reverend Steve Cole in the audience?
You did.
Okay, well, he mentioned this in a community talk, 8 or 9 months ago in the Bernathen church, like what they used to call Friday supper, how discrete degrees is the real telling point as to whether you can theoretically do this or not. And I think that's true. Another question when you go to AGI is, will AI become sentient? Will it become a thinking, self-aware thing? And my little final example is this beautiful quote that I think many of us love from the Gospel of John, from the beginning of it. In the beginning was the Word, and the Word was with God, and the Word was God. Why do we find delight in this and many other passages, which many of us do? Maybe the question should be, will AI experience delight? I don't think so, but there's a step that involves more than just information and even involving affections. Oh, do we have time for any questions?
We got 10 minutes for questions and breaks, so yes.
Okay.
Any questions out there?
Should I leave my screen up or go back to showing my face?
I think we'd like to see your face, to be honest. We'd love to see who
There
you
we
are.
are.
So I can then use my mouse and sniff. And there you are. And I think I can view.
Okay, I can see a large chunk of the audience, many of whom I know. I got to mention, I have really, Dr. Seminade told me this, but I have really top students in CS 220 this term. So that's been a pleasure for me. And there some of them are, and some of them are going to be speaking.
All right, any questions out there on the presentation? Yeah, Stephen Cole.
Okay, I lately read or actually listened to a book called The Myth of Artificial Intelligence by Eric J. Larson. And one of the things he thinks that distinguishes human intelligence at this point from artificial intelligence is, you mentioned induction and deduction, but he says that there's, he uses the term abduction, which he got from Charles Sanders Peirce.
Mm-hmm.
I like Peirce because he was unashamedly Swedenborgian. But he
That's
talks
good.
about, which I think, as I understand it, is basically the ability to form hunches. Or I mean, I put simply, people get hunches about things and pursue an investigative, logical, intelligent process based on those hunches. And that without that, we wouldn't have human intelligence. And he's saying he can't see how we're gonna be able to model that or simulate that. I just wonder what you think about that.
Well, I generally agree with it, although I would lump hunches, which is certainly, I mean, the creative process, when you're working on a problem that's unsolved or that you haven't solved before, you need hunches. I mean, I think that's like that and so forth. So that is, in a sense, I don't like the word creative because the Lord creates and we don't, but the intuitive processes that we use to get to things. I would tend to lump that under induction, but I'm not so sure that that's the right place for it. It's certainly not deduction because you don't have the principles yet. You're trying to figure those out. But that's an interesting thing, Steve, that you raised.
I'll add a little bit. I went to a talk on using artificial intelligence to diagnose skin cancer. And so these photos of skin blemishes, and they ask a doctor which ones are cancer, and they ask an AI trained image detector which ones are cancer, and the AI did a little bit better than the doctors. But
Wow.
you know what did the best? What did the best is a doctor examining the results of the AI to work together. And when they work together, that gave you the best predictive quality. So hunches alone can lead you down a bad path, but hunches plus good AI seems to be the winning combination.
Mm-hmm. Mm-hmm. For sure.
Any other questions out there?
I'm just amazed that, for example, Google Photo is able to identify photos of 1-year-olds through 40-year-olds, and not perfectly, but they're able to do that analysis. And just thinking now, how do they do that? Because the 1-year-old sure does look different from the 40-year-old.
Yeah, that's amazing. I hadn't read about that experiment. Do you mean the same person traced over a lifetime, or?
But it's, we have a huge storage in Google Photos of family photos. And I can say, find all the ones of Ian. And it'll go all the way back to his childhood, teenage years, etc. And largely quite correct. Even a fraction of his face in a
That's
photo.
interesting. Yeah.
Little scary.
Yeah. That is. I hadn't heard of that experiment. Obviously, we can do that, but I'm surprised that AI can do it. There must be enough similar threads in there, and it's able to pick those out. I would call that induction, to form some sort of a rule whereby it can do that. But very interesting.
Next flip.
Nobody has said anything from the writings. When I got this because of chatbot, because I was trying to put together a presentation from TCR 230, it might be thought that the doctrine of genuine truth could be acquired by means of the spiritual sense of the word, of which we are granted knowledge by correspondences. This is the clincher. A person who knows a few correspondences can falsify the word. That's the clunker. And finally, the spiritual sense is not granted to anyone except by the Lord. So I like the answer of the hunch model and going into this. I'm a step in the right direction. Do you ever come across TCR 230 and wonder about how we can falsify the word with this? I'm a rank amateur. I can do it. I can promise you. Other people.
Well, I would have to ask Steve Cole or one of the ministers, but yes, I've come across it, and yes, it sort of bothered me. Wait a minute, you mean that knowing a little can lead you astray? And I haven't fully resolved that yet. I see that Steve David came in, and Levi's going to talk about his stuff, I think.
Oh, yeah. So I think that intrigued me a lot with the sort of knowledge tree thing. And I think it reminded me of the way in which the writings sort of cross-reference each other, like especially if you see in DLW, like many references that went up, so on and so forth. We're up to our current Celestia. The thing about the knowledge tree and the thing of splitting and passing those different ideas, I was wondering if, especially if you had an AI that was specifically trained to focus on literature stuff, then it could perhaps make those connections and connect them up to different passages that then it splits into maybe the same ideas. It could make sort of a knowledge tree throughout multiple books of ideas.
Mhm. I have not delved into the knowledge graph thing very deeply. I would love to do that and see whether it can produce falsities or truth, but in particular, whether it can make, I mean, the people that, could I make a knowledge graph that's as smart as Steve Cole? I don't know. But, take a very experienced scholarly minister that knows a whole lot and can make all those connections. I just pick on him as an example because we're friends. It would be a long way before we could do that. But it's probably worth the experiment. I think I'm going to focus a little bit more on the answering incoming questions because I think that's easier to do. And there's been some pioneering work in that you'll hear about in a moment.
That was Eve, not Lucas. I'm sorry about that. Apologies for getting your name wrong. So we have the next talk in about 3 minutes. So if you want to get some refreshments, feel free to do so. Thank you very much. I hope you can stick around for some of the talks, Chuck. I want to appreciate you for giving that talk.
Thank you. Yes.
Next talk in about 3 minutes. Stay please. I'm going to steal the screen. Oh, yeah. Oh, there we go. Well, oh, well. It's no problem. Yeah, similar. That's what I'm saying. So I would have that where I was for that long. It's a get her down here. History. So how it's works about the figures out how to and I was trying to talk about so I raised do all folks see the opening slide? Having here. Chucky, give me a thumbs up if you see me open the slide. And I can tell you that. Which side are you getting your thought? Yeah. So I'm trying to. I did that. That's the number at that. That's back to normal. Right. That was my question, but I think. He was saying, can I Hebert, can you still hear me? Can you give me a thumbs up if you can hear me? Anyone want to?
Anyway, he was saying.
Volume is going. Know why my volume might not be going through. Chuck Ebert, can you hear me?
Yes, I can hear you, Neil.
Okay, great. Can you see Dan Key's opening slide?
I see Dan Keyes, yeah, addressing racial bias and facial recognition, yeah.
All right, please come take your seats. We're ready for our next talk. We have Dan Keyes talking about racial bias in facial recognition technology. Please stay forward arrow through. Take it away, Dan Keyes. Thank you for me.
Well, good afternoon, everyone. My name is Daniel Keyes. I'm a senior here at Bernathen College, currently getting my degree in math and computer science. Today, I'll be talking about the racial bias that can be found in facial recognition technology. So first, just a quick agenda of what I'll talk about in the presentation. I have a short intro, and then we'll go over my thesis for my senior paper, which is what this presentation is based on. Then I'll go through an explanation of facial recognition technology, how it works, how it's used by police, and how often it's used. Then we'll go over the three main types of bias that can affect these systems and the consequences of said bias. And then we'll look at three possible solutions that can help mitigate or prevent these biases altogether. Then a short conclusion and time for questions. Let's get started. First, I want you to imagine this. Imagine being pulled from your home, handcuffed in front of your family, and accused of a crime you did not commit, all because a computer said you did. This was the reality for three men of color: Robert Julian Borchak Williams, Michael Oliver, and Ajir Parks, who were wrongfully arrested due to errors in facial recognition technology. Sadly, their cases do not stand out, as this has happened to many other people. For example, a Black woman named Portia Woodruff. Portia was 8 months pregnant at the time and getting her daughters ready for school when the police came to her door and arrested her for carjacking. She was held for 11 hours, interrogated, and charged for a crime she did not commit. It's inaccuracies in facial recognition technology that can have these profound consequences, including wrongful arrests like these, or even failure to arrest certain individuals. The flawed training and deployment behind facial recognition technologies only exacerbates these social inequalities that we already see today. And so these consequences then raise concerns about the fairness and accountability in our country's surveillance practices. Which brings me to my thesis, which reads, the widespread use of AI surveillance has exposed systemic biases that disproportionately affect marginalized communities. Addressing these biases requires a multifaceted approach involving diverse training data, robust regulatory oversight, and increased transparency in AI processes to ensure equitable outcomes and foster societal trust in AI systems. Now, that's a lot to get into, and so the first thing that we need to establish is what is facial recognition technology and how does it work? So facial recognition technologies, or FRT for short, are different computer algorithms that recognize human faces through facial features in photos or videos. The basic process of how they function is they'll first collect data, so the image of a face, and then it will look at the geometry of the face. It includes the eyes, nose, ears, mouth, things like this. And then AI algorithms calculate things like the distance between the eyes, the depths of the eye sockets, shape of the cheekbones, and the contours of your ears and chin. Then this new calculated data is made into numerical code called a face print, which is not too dissimilar from your own fingerprints. And then this face print is used and compared against a database of other known faces, and that's how we get matches. So we know how it works, but how often is it really used and how is it used? Well, the purpose of facial recognition technology in policing is for the automated identification of individuals related to any sort of crime. This can be the actual suspects, people who are wanted at points for their arrests, or even the victims or witnesses if they want information from them as well. And how widely is it used? Well, according to a study done by the U.S. Government Accountability Office, 7 different law enforcement agencies within the Department of Justice and Homeland Security, such as the FBI and Secret Service, use facial recognition to assist with most of their investigations. We know it can be widely used, but it's hard to get a direct number of how often it's used unless we look at a specific tool. So we look at a specific facial recognition tool called ClearView AI, we know it to be used by federal law enforcement and police departments nationwide. In 2022, it had over 1 million searches used for policing, and in 2023, the usage doubled to over 2 million. So it is used quite frequently. And this increased number of uses over the past couple of years have shown more errors in this technology. And so then the more errors then beg the question, well, why are we having these errors? And the reason it's happening is because of the bias, the racial bias specifically present in these systems. So first, I want to go over the 3 types of bias. Our first bias is systemic bias, and this comes from practices of institution that can lead one group to being advantaged while another disadvantaged. You can think of this as cultures of racism or sexism that could affect the companies that develop these AI models or the different policing systems that use them. There are also human biases. So these are biases that we hold in our own minds that can inform our own decisions and actions. So this can be the actions of a single developer training or coding these AI models, or a single police officer who's making these actions when they use them. And the last and arguably most influential and important bias is statistical or computational bias. These biases come from errors that are a result of the training data not being representative of the population the models are being used on. And to be clear, this type of bias is not just shown in a few facial recognition models, but most, if not all, of the ones currently being used. A study done by the National Institute of Standards and Technology, which evaluated over 189 currently used facial recognition models, found that across the board, all 189 of them were the worst at identifying women of color because of their lack of representation in these models. So the bottom line is that these AI algorithms do what they're told to do. They can't fix errors in the data they are given. The answers they give will only be as good as the data they are given. So once the model is trained on inaccurate, or in the case of facial recognition, incomplete data, it then solidifies this as this false information or incomplete information as the truth, and then causes errors down the line. And the errors that happen are false positives and false negatives. A false negative occurs when a facial recognition system fails to recognize a person who's present in a database when they should have been identified. An example of this could be someone who has a warrant out for their arrest. Facial recognition is then used on them if they were seen in CCTV footage or something like this. And then it comes back negative, so they're able to evade arrest because of failure of the system. A false positive can occur when a facial recognition system incorrectly identifies or matches a person to someone who should not have been matched or identified. These are examples of wrongful arrests that I stated before. And to drive home this point that these really are not that uncommon, I want to give you another example of a man named Randall Reed. Randall Reed was a 28-year-old Black man driving to his family's Thanksgiving dinner in Georgia when he was pulled over on the side of the road and arrested for a crime of jewelry store robbery in Louisiana, a state that he had never visited before. He was then held for over a week and interrogated, and it was only during these interrogations that the police realized we had the wrong guy and let him go. So it's instances like these that harm people in many ways, and it can affect people's freedoms, well-being, family relationships, future employment, and even their financial status. So then what can we do? What are the possible solutions that could help mitigate or prevent these biases altogether? Well, the first and arguably most crucial step is diversifying the training data. Diversifying the training data will help reduce bias and can lower the rates of both false positives and false negatives. This will only lead to fairer and more equitable outcomes for everyone when the systems are used. And as previously stated, all AI models, including those used in facial recognition, learn from the data they are trained on. So if the training data lacks diversity, then the model will most likely perform poorly on underrepresented groups. So just by including diverse data sets that include various ethnicities, ages, genders, and any other demographics, these models can learn to be more accurate and thus be more effective in the job they're supposed to do. Next, we can look into things like government oversight, which can help set standards and fairness for accuracy and accountability in different AI systems. The first oversight the government could put in place is mandatory bias audits, which is something the US government has actually already thought about. The White House has a blueprint for an AI Bill of Rights, which focuses on how implementing these bias audits can help identify and address bias in these AI systems before they're deployed out into use for policing. So the audits would be proactive and help prevent discrimination caused by AI and can prevent harm. They'll serve as a critical checkpoint for developers, allowing them to test their models against diverse data sets, again, before the potential harms of deployment could be found. And I think lastly, we need to see transparency in AI systems across the board. AI systems are essentially black boxes to most, if not all people. We can understand the inputs and the outputs, but everything that happens in between is pretty confusing and hard to understand. So I think legislation passed by Congress should mandate that law enforcement agencies disclose to the public how facial recognition tech is being used. This can include things such as the source of the images, how these images are being found, and the databases involved, and the frequency of facial recognition's usage. While citizens may not require a deep understanding of the underlying algorithms that these different facial recognition systems use, I think they should still have a clear explanation on why it's being used and what measures are being put in place to hold developers accountable and prevent these harms from happening in the future. So in conclusion, if these changes are not made and facial recognition systems continually make errors, they will continue to be seen as unreliable and cause harm to many individuals. As we have seen, certain groups have experienced higher error rates, causing facial recognition tech to be biased and unfair towards them. A survey done in 2023 showed that only 39% of US adults believe that AI was safe and secure and okay to use, and that was down 9 points from the previous year at the same study. The same study also showed that 85% of US adults support a nationwide effort to provide more transparency and safety into the AI systems that are currently being used. So with the increasing use of AI in all facets of life, this increasing distrust in AI and harm done by AI does not just affect things like policing and facial recognition, but it can affect AI in a lot of its use cases. So when developed responsibly, AI has the power to enhance security and serve the needs of our diverse communities. Addressing the challenges found specifically in AI-driven facial recognition technologies is not only a technical necessity, but also our own moral obligation. Thank you.
So, where does the training data come? What's the population that comes from in the first place?
So that is kind of up to the developer for the most part, who they decide to train this data on. There are examples that I found of some pretty bad facial recognition systems that were basically just trained on the guys who made it. They just got basically the employee photos and trained it on that. And that.
Wow. So, but but surely, a more mature system would have a larger database to train on. Now,
Yeah.
are they people who are in jail, or I mean, where does it come from?
So again, it's up to developers for the most part. I know if the US government decided to do it themselves, they already have a stash of over 650 million images of US citizens that they use for searching with these different systems. So I assume they could train it on that as well. And part of that are people who are already incarcerated and already arrested.
So what I'm kind of hearing is maybe a third of the people in the room here have their images in the database.
It's actually most likely probably all of us.
Driver's license photo.
Driver's license photo. A big one too is the US government made a deal with Facebook a couple years ago, or more than a couple years ago, that they could use any photos posted on Facebook or Instagram to add to this database, because a lot of the times you tag somebody in a photo, and so not only do they have a picture of your face, but it's annotated with your name as well, so they can use that data very efficiently.
They have this huge database of cats.
Oh, good. All right.
This is an anecdote, not a question, but I think it's in support of what you're saying. When I visited Saudi Arabia, I was in a room with about 112 guys, and they showed me that they open each other's phones, iPhones.
Yeah.
Because I guess the database wasn't very diverse.
Yeah.
Jared, if you want.
So I don't know if this would come up in your research, but did you find like how well do these programs handle like facial features that can change, like facial hair, glasses, or tattoos even? Do you know?
Yeah, that didn't come up with any of the things that I found, so I don't know. Sorry.
Do you, well, first of all, I'd be curious, how many people's phones are good at recognizing your faces when you use the face recognition in the room? Like mine fails probably 4 out of 5 times. Does it work for everybody?
Yeah, most of the time.
Yeah. Okay, well, that's pretty cool. Does, you mentioned that different, I think you said women of color.
Specifically, yeah.
Is that, is it because of low data, or is it because there's like, is it Asian women, Hispanic women, Black women?
So it's just low data across the board for a lot of the AI models. I can't look at them directly, but I could look at these studies that did these, sweeping things across the board of looking at all the different ones. And it was just because of the lack of diversity in the training data that was focused more on middle-aged men, just usually that's how it was. It was worse at identifying women specifically because there was more men. And then and a lot of these models that were identified were ones made in the US. So it's a lot of white guys who were doing it.
Okay. So it's not that women's faces are.
No, it's not because they're hard or anything. It's specifically because of lack of diversity in the training. Yeah.
So I do have a question. So not just for facial recognition, but in other areas I've come across the notion that even if the AI model is biased, humans are worse in their bias. And I'm wondering if that is true in this context as well, that maybe there's bias in the data and that means resolving, obviously, but asking humans to just make decisions independently of AI would lead to more bias.
Yeah, and I also think it reinforces those human biases. So for one of the examples I was looking at for all fluoresce, I don't think I included in my presentation, it was not only was there an eyewitness account of someone who did it, but then it was backed up by AI. But it was the AI who did it first. They basically used AI and then said, "Is this the person you recognize that AI chose?" And they went, "Yes, it's definitely the person." It was not. So it can reinforce our own bias.
I don't know if this is part of your research or not, but did you find any lawsuits that were driving some of the change in the usage of these systems?
No, there really isn't. I think I found one thing. I forget which state it was in the US, and they were the only state that I noticed that mandated any sort of change with transparency. So they were doing they had to release every so often how many searches had been done by certain police departments and things like that, but no sweeping change of any sort of trying to push for diversifying any training data or anything like that. Yeah.
Do you know at all the statistics of how accurate it is, like how often they get things wrong and how often? It's higher with certain marginal.
Yeah, it's hard to say exactly just because, like I said, with all these studies, it's not looking at one specific one, but like I said, with that specific one, it's 189. I think it said for looking at different models, it could be a difference of like 3 to 100 times worse on those specific. Yeah.
Thank you again. You're the third one here. Declan, you're the third one on there?
Yeah. It's out of the way.
I mean, we're very happy to be here. Sorry.
All right. Out of your way. We now have Declan Williams, another one of our senior essay students. And take it away. It's all you.
All right, let's go. All right, so I'm Declan Williams. I'm graduating from Bernathen College with a degree in computer science and math, an IB major, and I also am getting a minor in philosophy. And I'll be talking about genetic algorithms and artificial sentience. This is a topic that interests me because it combines all my fields, math, computer science, and philosophy. And also, I think it shows a unique application of philosophy, which I will get into later in the presentation. So, first, the agenda. I'm going to be giving my thesis, which is based off of my paper that I'm writing. I'll talk about how the genetic algorithm works, and this will lead into how neuroevolution works. And then I'll talk about AI and sentience, and then the pursuit of artificial sentience. So first, this is my thesis. It's a jumble of words, but through my presentation, hopefully this will be explained further. But for now, I'll just read it out to you. With the combination of multiple AI technologies, humanity is coming closer to facing the reality of a sentient artificial being. But the uncertainty of this field ultimately pulls the pursuit of artificial sentience into question, proving that the need fulfilled by pursuing artificial sentience is not only technological improvements, but also advances in the philosophical knowledge of the general public and advancements in philosophy itself. So this will be further explained hopefully throughout my presentation. So first, let's go over the genetic algorithm. All of my notes. That's good. So this may look like a flowchart of complicated words, and that's kind of because it is, I guess. But I will hopefully, through explanation, lead you to a greater understanding of what the genetic algorithm is. So first off, the genetic algorithm is a thing that is used to solve certain problems or reach the optimal solution to certain problems. So to do this, genetic algorithm creates a population of solutions that could solve this problem. This population of solutions is evaluated for the best solutions of this population. This is the fitness value of the population. Now, all these solutions, some of these solutions are selected if they have the greater fitness value, and the rest of the solutions that weren't able to optimally solve this problem are culled. So now we have a small subset of solutions which can potentially solve this problem. These solutions are then cross-bred. This means that the two solutions will be mixed together and combined, and then these solutions are mutated. And this is to form more variety in the solutions. So after the crossbreeding and the mutation of the selection of potential solutions, now we have a whole new population of solutions. Now this whole new population, if none of these are able to effectively create an optimal solution to this specific problem, then the process repeats itself, and this whole new population is evaluated again, and then so on and so forth until the termination criteria is reached, meaning that there is one solution among one of these populations that is able to effectively solve this problem. Hopefully that is a good explanation, because now we're getting more complicated. Neuroevolution. This is the combination of genetic algorithms and neural networks. Essentially, it uses the genetic algorithm to train neural networks to become better at what they do. I can give the hypothetical of an image generation neural network. In image generation neural networks, the genetic algorithm would be applied. It would look at all these simple neural networks which are trying to create an image. It would see, are any of them good? How well do they do this? It would select the ones that actually are able to generate an okay image, or the best ones that are able to create an image, and cull the rest of them. And then it would, again, this is the genetic algorithm, it would repopulate, mutate, and then with this whole new population, see, can we create an image now that is actually realistic? And do this over and over again until one solution or neural network is reached that can actually generate a realistic image. This is just an example of two neural networks being crossbred. So each of these squares represents a connection between the nodes, and the similar connections between these two neural networks are kept, while disjoint connections are removed and excess connections are added. And then there's this more complicated but unique neural network, which is a result of the crossover of these two neural networks. So neural evolution is a combination of neural networks and the genetic algorithm. Now, neural networks were created to mimic essentially the human process of brain functions. So the genetic algorithm, as you might see through it's creating a population and culling, is created to mimic the human process of evolution. And this is a persistent trend actually in AI technology, is the constant mimicry of human processes. And this neuroevolution is just combining these two processes. As we consistently are mimicking human processes, the question is often posited: what is required to create artificial sentience, or is artificial intelligence sentient itself? So before I talk about is AI sentient, I would like to first provide the reference point of what is a process required for life. These are some of the agreed upon processes or semi-agreed upon processes within philosophy that are needed for actual living being. These are maintenance of boundary, metabolism, stability, information storage, regulation of the internal milia, growth, reproduction, and irreversible disintegration or death. Now, you may see that neuroevolution actually does have some of these processes which are needed for life, or at least it mimics some of these processes. These being something like reproduction. Neuroevolution is able to reproduce nodes over time and create more optimal solutions, and also irreversible disintegration. A revolution culls the population and sees what are best and culls the ones that aren't good enough, aka it kills off these not good enough neural networks. Now, it does have some of these processes needed for life, but you'll notice that it also doesn't have a lot of these processes too, such as metabolism, self-explanatory, and also maintenance of boundary, which is AI can't recognize the internal self versus the external world. So why am I providing this reference point of life? Well, I'm providing this reference point because currently in the philosophical world, there isn't really agreed upon processes that are required for sentience itself. It's a bit muddy. So if sentience itself, we don't exactly have a good definition for, how are we going to tell if AI is sentient? And that's the main issue, is asking, is AI sentient? Well, it's just an unsatisfactory answer of, we don't really know. So why am I focusing on this question? Is AI sentient? If there's so much disagreement and discussion that doesn't really result in too much satisfying answers. I'm focusing on this because I wanted to show that it provides unproductive answers and to show that we need a shift in the question. We shouldn't be questioning, is AI sentient? Instead, I think we should be questioning, how will we discover if AI becomes sentient? I think this question is good because it hinges on how we are able to recognize if AI does become sentient. And I think it provides a better avenue to understanding sentience and discovering what sentience is itself. I also think this question is good because it displays the direct application of philosophy within artificial intelligence. This question, how we discover if AI becomes sentient, has the underlying connotations of, we should be discovering if AI is sentient because there are consequences. And these consequences being such as, if we develop an artificial sentience and we can't know if it is sentient, then we won't know if we're accidentally going to harm this being that is sentient. Or the more science fiction answer, the consequence, if we can't know when an artificial intelligence becomes sentient, how can we prevent, catastrophic AI takeover? So these pressing concerns, I think, allow a previously niche philosophical question of what is sentience to reach the mainstream as AI has developed and become increasingly prevalent in our daily lives. And it also brings this discussion of sentience from hypotheticals to an actual physical domain, as we actually need to know what sentience is to be able to know how to prevent it or know how to treat it. And this, I think it just generally provides a broader general public understanding of what sentience is, as it is a key part of life. And I think, that's it. And those are my sources,
Standard.
So I was curious, you were talking about sort of the reproduction of the models and how they'll pick the best options from any given pool they have. Is there a safeguard against things going completely wrong and it starts unknowingly picking the worst solutions to a problem and that still work? Like, let's say there's a giant sinkhole in the ground and let's use AI to solve this, and it goes over a bunch of iterations like, well, there's a bunch of people standing next to the sinkhole. If we just push them all in, that'll fill the hole. Right? Is there training to prevent sort of runaway bad answers from compiling and getting worse and worse?
Yeah, so optimally the fitness value, the thing that's determining how well it solves the solution, wouldn't include let's fill it with humans. But also the mutation itself, the reason there is a mutation is to avoid these things that are called local minimums. It's to try and get it out of this local minimum, which is able to solve the solution, but maybe not that well, and find the actual minimum, which might be a solution that solves it more effectively, and it's actually the best solution. And that's what mutation is generally for. Yeah.
Good, Dave.
Would you care to talk about the role? I mean, you got this computer program, but then you have to connect it up to robots,
Mhm.
machinery, and so forth and so on. And it seems to me that's where the sentience thing is going to start to show up. So, for instance, at our retirement community, we have robots that serve dinner.
Mhm.
Now, you could program that robot to be grateful for me saying thank you, but you could program it to be angry, you know, do something like run over me or something if I didn't say thank you. So sentience starts to come in when you connect to the real world, I would think. Have you got any thoughts on that?
Yeah, a lot. So while I say sentience is a disagreed upon thing within philosophy, there are some things which generally people think might be needed for sentience, and a lot of it maintains to like having an actual physical form. So the ability to actually be able to feel, if a robot is actually able to feel the outside world, or if it's able to actually like exist and recognize itself, the difference between like itself and the outside world. Those are like two things which I think sentience might be required for sentience, and that an actual physical body might be needed for. So I think if a physical body is like developed for, and as robots become more like developed, then it's possible that AI that would increase the likelihood for AI to become sentient. Yeah.
This might be a silly question, but we were talking a lot about sentience. So I was just curious about how you personally are defining sentience. Like, are animals sentient? How about plants?
So sentience is like the thing that, yeah, we don't exactly know, but I think plants aren't sentient, animals are sentient. I'm going off of mainly a Swedenborgian perspective. He says the human is divided into three parts: the sentient body, the mind, and the soul. So the sentient body itself is just the physical makeup, and this is something we think of sentience as something that has an analog to the mind. It's not actually like it's not, Swedenborg says it's not a real mind because it doesn't have real understanding or will, but we think of sentience as something that has analogs to understanding or will. So something that like is able to do something without being provoked to do something, just because it's sort of like the hunch thing. It's just able to like do this thing without input from the outside. It just comes up with it itself. Yeah.
Yeah, so it's interesting hearing more about the genetic algorithms. And I saw a video the other day about how there was some experimentation, and some people were starting to think that if you came up with the way that you're training models using a genetic algorithm, it might perform better than basically having human intervention or human strategies like imposed on the model. So I'm curious if you have any thoughts on that, because it seems like you mentioned a local minimum. To me, it kind of seems like all of the models that are sort of flagship right now are around the same like level of usefulness. And I wonder if there's sort of at a local minimum, and if we started from scratch with the genetic algorithm, they could sort of find the highest or a higher plateau.
Yeah, it's definitely possible. The thing there is like ChatGPT and stuff. They do use it to some extent. Most of it is like actually deep learning, but that would be interesting because that's like a crossover of that probably couldn't happen because they're all like owned by different companies. Of like ChatGPT, Grok, and like different AI things. That definitely could be a way, I think, forward for like creating a better AI cross breeding in different language models. Yeah.
So I see, let's go back through here. Tommy?
Yeah, so I found it really interesting how you sort of compared the differences between evolution and nature and algorithm, and that nature sort of like selects for like cases like failure cases. You said you could what was calling.
Yeah.
And how, at least from my estimation, the only force in AI that can cause that is more business needs.
Is what?
Business needs. Like the idea that like a given iteration of like an AI is not meeting whatever need that the AI is trying to be changed towards, which, I mean, research aside, often it's someone's trying to make money off these things.
Yeah.
So I'm curious from your estimation, can like the survival rules that business and finance create for AI, anything that would push it more towards or away something that can help sentience?
Ultimately, the how it evaluates that, like, that fitness function, which is the thing that evaluates how well this problem solves. I mean, this solution solve this problem. I think would push it more, perhaps more business, but also generally like if the fitness value has the goals, the ultimate goal of like humans a lot of time is just like survival and survival of the fittest. And typically the fitness value in a genetic algorithm isn't just like survive because it's not in the real world. The fitness value is like, you know, create a value of X that best solves this function. So yeah, the business might, but I think it's mainly like existence, I guess, in the natural world and the goal of like survival over just like a random fitness value, which is used generally. Yeah.
You have a question?
Yeah, it's not, I don't know if I can articulate it, but there was a slide you had with I think when you were combining the genetic algorithm with the neuro evolution, but do you think it's possible that creation, that when God created the universe, he went through a process like that because there are all these like the physical constants of the universe, if you tweak them a little bit here, there, and the other way, the whole thing collapses. So is this an optimum from a divine AI process?
That's good. Yeah, I think honestly that might be. I would have to like actually study more about the religious perspective, but that is definitely like it's possible that through evolution, and we are one world that we know of with like real sentient conscious beings, humans. It's possible that like through the genetic algorithm, God was trying to find a recipient that could best like glorify him, have be best follow him, I guess. Yeah. It's possible. I don't
Imagine a cutting room floor full of failed.
Yeah, if you weren't able
That one that works. Let's go AI.
So teaching stats right now, so I'm thinking about relative solutions, not teaching calculus, so thinking about absolute solutions. So when you're talking about the neuroevolution training where they all settled onto one answer, I was thinking, well, but maybe them all agreeing isn't actually better. And I wonder about what it would look like to create a model that had all some pretty good answers and allow all of those versions to continue to coexist with different answers. Thinking as an analogy, monoculture isn't inherently good because even though it grows really great potatoes, make great French fries, it sets us up for disease and whatnot. And so I don't have the rest of the analogy prepared for what I'm wrong with this monoculture, but just thinking about is there support for one solution being the best path here?
Yeah, so there is actually a thing that a lot of neuroevolutionary models use called like they use like species essentially. So they'll program into the model itself the need for like diverse species. So as it evolves over time, perchance there'll be like one solution that solves it but in a different way. Like one solution that solves it but in a different way, another one. And these would be grouped into like different species because they have like similar connections. And then over time, it would like evolve and try and keep different sorts of species until maybe there's one species that, isn't doing that well. It'd be like, all right, you're gone. But it does generally try and actually keep, varied solutions sometimes through species. Yeah.
Got time for one more. Who's really eager to get their question? Okay.
It's going back, you touched on some of the theological stuff, but like soul. Like initially doing it, then I was fully on like the whole side of, well, if we have like a soul on that, like that's the real you, and then the external portion shell like so your sentence is there. But another thing that like in order to develop plants and animals, they have like a rudimentary soul, and they're like rudimentarily sentient, even though they don't have an internal soul. that goes on after they die. And so I'm wondering, is that something that also needs to be passed on, or the long question of, or can AI perhaps being in the form, external form of the mind, would also have like a rudimentary sentence like an app?
Yeah, that's the yeah. So based on my research on the religious perspective, I'm still not done that part of my paper yet. So I need to like confer with the actual minister probably more about it. Based on my understanding, I think it would be possible. What I saw is that like animals have analogs to the mind. Like they have analogs to understanding and analogs to will. And these things appear like they have a will, appear like they have a soul, but in reality, it's only like we only perceive it that way. They don't actually have it. They only exist within the physical part, the physical like chemicals and neurons that make up their mind. And in that sense, I think AI could achieve sentience because because it's just a physical thing that is needed. It doesn't actually need the will or understanding. It just needs these analogs to look like it has will or understanding. And so that's what I know.
So thanks again. Had a break built in after the next talk, so Levi, if you want to dive right in, and then we have a break built in after this talk.
And so. Well, hello, everybody. My guess is that many of you are familiar with the New Christian Bible Study website. And both this past summer and this term, I've been lucky enough to get to work on the site as a programming intern. And in my time working as an intern there, I've been working on a few different problems for which AI actually provided a meaningful contribution. And since we're at an AI Symposium, I thought it would be fitting for me to tell you somewhat about each of those problems and how AI contributed to them in the hopes that it might inspire applications of AI for yourself. So I'll talk to you about our Bible words and phrases project, our chatbot, and then finally some ideas for how artificial intelligence could be used on the site in the future. So I'll begin with our Bible words and phrases project. If you have read the word on New Christian Bible Study, you likely have noticed that in text there are word highlights, word and phrase highlights, I should say. So in the beginning is highlighted, expanse in the midst of the waters is highlighted, and day is highlighted. So if you hover over one of these highlights, you'll get a pop-up like this one. And this pop-up tells you basically a summary of what Swedenborg has said in his various explanations about the word or phrase. And so the idea is that you want all of your resources for understanding the word in one place. And so if you can get them rather than going and looking up the associated references in all books, you can get them right in the text, then that's great. A lot of the work for this was done beforehand by several people who have gone through and basically indexed all of the explanations within the writings. The most recent of these, which built on the existing works, is the Dictionary of Bible Imagery by Alice Seegers. And as you can see, it has dictionary-like entries for different words and phrases that would appear in the word. And so we have this document and we've parsed this document to get a list of these keys or the words, phrases, and the explanation. When the time comes to actually apply those to the text, some words and phrases are very easy and some words and phrases are very hard. If you're trying to apply the word blood to everywhere where that happens in the Bible, it's pretty easy. You just search the text for the word blood, and then you add a link there. However, some of the concepts are a lot more complicated. There will be things like the chariot that Elijah flew on, or as you wish is the example here. And there are different expressions of that concept depending on which translation of the Bible you're reading. So in this example, in Jeremiah 26:14, there are lots of different ways where the idea of as you wish comes up. In one translation, it's as seemeth good and meet to you, or as is good and right in your eyes, or whatever seems good and right in your opinion, or what is right and good in your eye. I won't read all, but you get the idea. Lots of different. And so the problem is we want to be able to highlight the words and phrases in any translation of the Bible that you choose, not just one that happens to match the exact phrasing used in or that was in the Seeger's dictionary. So how do we recognize that these are the same? And the answer that I came up with was ask AI to do it. So you say, we're trying to find this concept as you wish. And maybe here's an example of how it showed up in one translation, as seemeth good and meet to you. And then given the text of the verse in some other translation, take out the part that's talking about the same thing, represents the same concept. And so this is just a snippet of my code, which probably looks somewhat like nonsense, but there are instructions for the agent here to find the phrase in the given translation that matches the phrase we're trying to find in the original translation. And I also give it things like the concept and the original translation to go off of. And so with that, we get pretty good results for matching the concepts in all the translations. So there's the first project I wanted to tell you about, the Bible words and phrases. And now I'm going to move on to the chatbot, which is probably what you're most interested in. So for those of you who are not familiar, on the home page, there's a box here where you can enter your question for the chatbot, and it'll take you to a page that looks something like this, where your question is up here and it answers down here. I think it's a very telling question. And you'll notice that it has links to further reading built into the text, which you can click on and go and actually read, which is something that takes some effort to. And so part of how that's built is with this idea of related passages. And below your answer to each question, you can also ask for related passages from Swedenborg's works and related passages from the Bible. And it will basically find passages that tend to have a similar meaning to the question you're asking. And that kind of seems like a strange idea that you can tell an AI to find similar meaning with this large corpus of words. And that's why I want to tell you a little bit about what's called a vector embedding, which is one of the core technologies behind how this chatbot works. And because this is sort of it's likely a foreign concept, I want to introduce it with a short video by the YouTube channel 3 Blue 1 Brown, who makes excellent math and computer science visual explainers. So he's going to tell you a little bit about, or he's going to show you a little bit of how vector embeddings work, and then I'll talk more later.
What is Hitler really minus Germany? This came up in a full video that I did dissecting what happens inside large language models. You see, when tools like ChatGPT process text, the first thing they do is subdivide it into little pieces, and associate each piece with a large vector, so a long list of numbers. This is called an embedding of that piece of text, and it's helpful to imagine these embedding vectors as directions in some very high-dimensional space, even if we struggle to concretely visualize anything more than 3 dimensions. Models that learn to embed words as vectors like this often encode a meaning into the directions of this high dimensional space. If you take the difference between the embeddings of man and woman, and you add that to the embedding of uncle, you get a vector very close to the embedding of aunt. If you take the embedding of Italy minus Germany, and you add it to the embedding of Hitler, you get something very close to the embedding of Mussolini. It's as if the model learned to associate some directions in this high dimensional space with Italianness and others with World War II Axis leaders.
So that idea, as you saw, basically you take any piece of text, whether that be a single word or a big paragraph or an entire book, and you sort of ask the model to represent that meaning as some list of numbers, some point in a very high dimensional space. Say it's R1536 is the model that we use. So it's 1536 floating point numbers that somehow encapsulate the meaning of this word or collection of words. And so hopefully that isn't mumbo jumbo. Basically, you're taking a big chunk of text and you're numerically representing what it means according to some model. So we did this with text from the Bible and from the writings. So here's an example of 3 chunks that we made. So in other words, we took, in this case, Doctrine of the Lord, and we split it up into like paragraph-sized pieces of text. And then with each of these chunks, we then did that same process where we sent it to OpenAI and we said, turn this into a numerical representation of the meaning of these words. And it did it. So now we have a vector space where the place within it where the vectors for these chunks points to indicates basically what they're talking about, what they mean. And so we can use that. When a user asks a question, we can take their question and embed that. So we put their question in the same vector space. So if the user asks, what is true charity? Then their vector is going to be over here. And also over there will be all of the different passages in the writings that are talking about what true charity is. And so by grabbing all of the vectors that are nearby to the one we're looking for, we can actually find relevant text, whatever the user's asking. And so that's sort of what this diagram is documenting here. The user asks a question. That question is turned into a search query, which is just text. And then we send that to OpenAI and they turn it into that vector representation. Then you compare the vector representation to all of the different vectors that are already in the database. And you take those back as sources and you use those to form your answer. So basically it's doing research. It's using the similarities in meaning between the user's question and what it already knows to find relevant passages. And so that's basically what's embodied in the chatbot is research built on this. And the technique diagrammed here is called research augmented generation, where you would then feed that list of sources into the large language model along with the user's question so it can make an informed, it can respond with information, not just from its sort of implicit knowledge, but with something you've actually given it that's from. Okay, so that is the chatbot. And then my third and final point is ideas for the future. So these are not fully baked by any means, and they're just sort of ideas I've thought of or heard that sort of make sense on this for the website and using the tools that we have available. So the first is bringing this technique of research augmented generation and perhaps large language models in general into the translation process in some capacity. This is a matrix or like a checkbox of which words are translated into which languages. And so if it's white, there's no translation. And we have lots of information that we could give a large language model to help it produce some sort of translation to give to people who speak these languages that don't have anything currently. We have, for example, in the Kempton translation, there are lots of notes about what the Hebrew and the Greek are really saying. We have lots of tools on the New Christian Bible Study website to parse the Latin of Swedenborg works. And so, given a bunch of information like that, it's not a stretch to see some sort of LLM being able to give us useful output in the translation. And the way this could show up is sort of easier than producing a full translated work is using AI to create personalized translations or summaries of specific passages. So I could very easily see this being a new button on the page where you've got this complicated Latinate English and you're not sure what's going on. And you say, I want you to translate this for me. And here are my preferences for translation style. And here is sort of my reading level. And please go ahead and produce a translation for me. And then it would go ahead and do that, possibly given a bunch of tools and information that were given to it. Then my final idea is somewhat obscure, but it's a semantic translation memory. So people who work in translation often keep this thing called a translation memory, where every time they translate a certain word or phrase in a certain way, it's stored to a database. And then the next time they come across that same word or phrase, they see, oh, I already translated it this way. And so in a similar way, you could sort of embed the meanings of everything you've translated so far, and then get that same notification and same looking back at what you already did when you're translating something that has a similar meaning to something you've already translated before, not just the same exact text. So those may have been some intense points, but I've told you about Bible words and phrases, the chatbot, and ideas for the future. And really the takeaway is there's a lot to explore with these new technologies that haven't necessarily been applied to their full extent in new church scholarship. And people like us can explore them. Thank you.
So on the semantic translation, just make sure I understand this correctly, is the idea here like if you had like a translation of one given work that you really liked the way it translated, but that translation has not done other works, you could say like train the AI on the semantics of that translation and then straight like this other book as if it were translated by the original translator. Is that to do with that? Or?
So that wasn't the idea I was going for, but I think that also is a good idea. There's this thing called fine tuning where you can basically embed you can distill certain values and behaviors in a model based on a corpus of work. So you can take that existing translation, use it to fine tune a model to emulate that translator, and then try to apply that to a new work. So I could see that being helpful in basically mimicking the style and tone of a certain series.
I'll make sure I get this side of the room. You have a question?
Yeah, but the chatbot, how long did it take you to do that, all that? When was like your start?
Yeah, so it wasn't all me. Steve actually might know more, but there have been several major versions of the chatbot. The first one was produced before I started being an intern at New Christian Bible Study, and it had sort of our first batch of embeddings. But now we're sort of creating a new embedding process, and basically getting clean, fresh embeddings with sort of newer techniques. Does that answer your question?
I was just looking for a time frame for how long it takes to get chat function on some service.
Started in May, about not quite 2 years ago. But we made a lot of wrong turns along the way.
I two questions, a little small. Firstly, you were saying your vector space is at 1536. Is there any reason you're stopping there and not? I mean, I know it takes a lot of computing power, but if you moved up to like R2000 or something like that, would that make your chatbot more accurate and would that like improve its quality? Is that something you do in the future? Well, so it's not something I do. This is all sort of OpenAI's world. Okay, so is that what specifically their defaults are? So we are we're sticking to an older embedding model just because we don't want to redo everything. I think they have some newer ones that might go a little higher in terms of number of dimensions. So, but yeah, I mean, seems like it makes sense to me. More dimensions, more fidelity.
Maybe one more question.
So maybe this isn't super entirely, but I'm curious if the Futures and Bible Study has any tools that would be useful for like sorting words in Swedenborg Latin. So like saying, what are the top 100 most common verbs that Swedenborg uses? Something like that exists currently, or?
I think so. Steve?
Well, we know all the words he uses. There's no interface that can get you the top 100, but it's pretty easy query.
I mean, I guess you could like, search it in like the new search type thing. I mean, I know your Bible Study and then sort by how many references, how many times. You can do a stepping search, say, verbs.
Well, I want to start the next talk at 3:53, so if you need a quick bathroom break or want to grab a little bit of food, please do so now. If you want to ask more questions informally, you can, but take a quick break. We'll start at 3:53. I gotta check it.
Oh, yeah.
I do a lot.
So moving to kind of standard thing. Get it go. Identify black minus the it's crazy. So then I'm looking at. But he's working. So I ask. So